Right, a couple of videos back we looked at finding the modulus and argument of a complex number in Cartesian form. The Cartesian form is the form we've been working with this whole time, so if we've got a complex number z equal to a plus bi, this is the Cartesian form. However, we can define the complex number in terms of its modulus and argument. So if you remember, the modulus of z is defined as the square root of a squared plus b squared from Pythagoras' theorem. If we draw a complex number z on an argand diagram, where this is the real axis and this is the imaginary axis, and this is a terrible diagram or whatever, and say our generic point a minus a plus bi is here. Okay. Our modulus is the length of this line that's supposed to be a straight line, and using Pythagoras' theorem, that's the square root of a squared plus b squared. Okay. And then we'd have an angle theta from the positive x-axis to the line, and theta is equal to arg z. Okay. And the thing to remember with theta is if we're in this upper half of the graph above the real axis, we go anti-clockwise round, and if we're below, we go clockwise round. This is so that each complex number has a unique argument, because if we could go either way round, we could go around, instead of knowing that theta is this way, our argument could mean all the way around here. So it just means that when given an argument, we know which complex number we're on about straight away. We just agree in maths that that's the range that we work in. Okay. So we can define our complex number z as being equal to mod z multiplied by cos theta, where theta is the argument of z, plus I sine theta. This is very similar to polar coordinates if you've ever studied those before. Okay. But this is what you should remember. So if you're ever asked to convert from Cartesian coordinates into polar coordinates, you need to find the modulus, and from Cartesian coordinates into modulus argument form, you need to find the modulus of z and the argument, and you write it down in this form. Okay, so that's simple enough. That's all we're going to look at in this video. There is another form to look at for complex numbers, which we will take a look at either in the next video or a couple of videos down. If you did enjoy this video, please be sure to like and subscribe. If you've got any questions about complex numbers or any other topics, feel free to let me know in the comments, and I hope to see you in the next one.